Hi everyone, today's lesson is a preview for section 2.4, but actually it's a review of composition of functions because we need to be able to identify which two functions are combined together to create a new function. In the warm-up, we're just going to practice finding f of g of x and g of f of x given two functions. So if we start with f of g of x, remember that this means that we first need to replace g of x with the function that it's equal to, which is the square root of 3x minus 4. And don't worry, we're not going to have to think about domain and range and all that. We just need to do the composition. And now that we have f of the square root of 3x minus 4, we're actually going to plug that into our other function, f of x, in place of the x. So we'll have 2 times the quantity, the square root of 3x minus 4, quantity squared, minus 11. When you square that square root, that undoes taking the square root, or it's the inverse operation. We're left with 3x minus 4. So distribute and then combine your like terms. So we'll have 6x minus 8 minus 11. Our final answer for our composition will be 6x minus 19. Okay, now we're going to switch it around and do g of f of x. When we do that, remember you start by taking out f of x and replacing it with the 2x squared minus 11. Go to your function g of x, and now we're going to plug it in there in place of x. So instead of the square root of 3x minus 4, you have the square root of 3 times the quantity 2x squared minus 11. Don't forget about that minus 4 on the end. Okay, next, simplify that. By distributing that 3, we get 6x squared minus 33 minus 4. So we have the square root of 6x squared minus 37. And that's our final answer. Okay, so we can see that the two compositions are different. They're formed in different ways, but they're, again, made up of two functions. So the reason why we need to look at compositions is that in the next section, we're going to be working with some more complex equations and finding their derivatives. But we can make things easier on ourselves. Of course, we have shortcuts that we're going to use. We have different rules that we're going to learn. But you can make things a little bit easier if you learn to look at functions, the more complex ones, as a composition. In other words, try to take your equation, take this equation, y equals the square root of 5x plus 8, and try to rewrite it or break it down into f of x and g of x, so that if we did the composition, we would end up with 5x plus 8. In other words, you can kind of look at it as there's an outer function and an inner function. For example, if I said that f of x was just simply equal to the square root of x, then I can identify g of x, the inside function, as 5x plus 8. It's a really skinny little 8. Okay, excuse me. So we can try to check it by saying y equals f of g of x. And let's see if this works. We'll have f of 5x plus 8. That tells you to plug this into here in place of x. And there you have it. We have the square root of 5x plus 8. So again, we can break this equation down into a composition of two functions, the outer function being the square root of x, the inner function being 5x plus 8. Okay, so we're going to apply that same idea to this one, y equals x squared plus 7, that whole quantity cubed. So notice that we have a quantity in parentheses, that's our inner function, and then we're raising it all to the third power. So our outer function will be to take x and raise it to the third power. The inner function, g of x, is equal to x squared plus 7. Again, test it out and say y equals f of g of x. So we're going to have f of x squared plus 7. So that tells us to plug this into here in place of x. And that'll give us x squared plus 7 raised to the third. Okay, so f of x equals x cubed. G of x equals x squared plus 7. Okay, one last one with the trig function. We have y equals the sine of 5x minus 2. So the outer function, f of x, will just be sine of x. And the inner function, the inside function, g of x, be 5 minus 2x. Again, test it out. F of g of x equals f of 5 minus 2x. And that's equal to the sine of 5 minus 2x. Okay, that's it for now. All right, we'll talk a little bit more about this in class on Monday. See you then.